good afternoon, good evening, good morning to every one of us, whatever where you are listening to. My name is Segun Oke, and today we'll be talking about line integral, and time permits us, we'll also touch the surveys and the volume integral so that we can quickly round up the integral part of the work and move on into the tensor aspects of the whole thing. So last week I gave us this question. I believe you can see my screen. So let's look at this particular question and see how we can solve it. So the question says, if A equals to 3x squared plus 6y, all in bracket I, minus 14yz j plus 20x z squared. We are asked to evaluate A dot the R from 0,00 to this and so on. So for A part of it says x is equals to t, y is equals to t squared, z is equals to t cubed. So you have to substitute. Let's solve the one of A. And how do we, but before we solve the one of A, don't forget the R. Let's do it one after the other. So when you have this, solution one says, if you look at this question critically, the question says we should solve ADR. For ADR, I believe we all have the question, or probably I should write the question. Let me just write the question, first one. Say, number one, if A is equals to 3x squared plus 6y I minus 14yz j plus 20x z squared k. Z evaluate integral of closure A dot the R from 0,0,0 to 1,1,1 along the following part C. Along the following part C. Now, the A aspect of it says S equals to T, Y equals to T squared, and Z equals to T cubed. So let's solve this one first before we go straight to, we use the same method to solve the second one. Then the solution says, for us to solve this, recall that the R is equals to the SI plus the YJ plus the ZK. but we know A, right? Our A will now be integral of A closure dot dr equals to integral of C, then put your A there. We know all our A to be 3x squared plus 6yi minus 14 yzj plus 20x z square k dot the xi plus the yj plus the zk. Now, remember I dot I will equals to 1 in this case. So we have this one to be integral of C. So if this multiplied by I is the x, J is the y, K is the z. So do it that way. So it's going to be 3x squared plus 6y dx minus 14yz dy plus 20x z square dz. That is our ADR. If my ADR, A dot the R is equals to this. Now, how do I solve for A? Question A says, if S equals to T, Y equals to T squared, Z equals to T cubed. That's a point 0, 0, 0 and 1, 1, 1 correspond to T equals to 0 and T equals to 1, respectively. Then integral of this A dot the R equals to integral of T equals to 0, 1. So remember the function of T now. X is equals to what? Anywhere you see X, you substitute T. Anywhere you see Y, you substitute T squared. The first one we have here is 3 S squared returns to T squared plus 6T squared dt minus 14 into T squared T cubed dt. Sorry. D of T squared, don't forget, because it's Y. Plus 20 of T cubed squared D of T cubed. So you have to be careful in this case. Remember, when you have, let me just quickly remind us so that when you for you not to ask too much question, look at it. When you have x squared multiplied by s3, what's the answer? Somebody should tell us.
X raised to power 5.
Good. Is x raised to power 5. Remember, the law of indices says a raised to power x, a raised to x raised to power n multiplied by s raised to power n is what? S raised to power what? N plus n.
Plus n.
So remember, that is the law. So all where you are seeing t multiplied by with a bracket, you will add them. Take note of that. We are using law of indices now. So I need to resolve this one now quickly by saying integral my t equals to 0 to 1 will be, if I want to do this one, the first one will be what now?
9 raised to power t squared.
9 raised to power t squared dt minus so what is the second one?
Sir, please, how did we get 9, sir?
3 plus
Because the power is raised to power 2.
3 plus 3 plus 2. 3 plus 6. Remember the okay, look at this. 2, look at what we are doing. 2x squared plus 3x squared is what? 5s squared. Do you agree?
Yes, please.
So it's the same thing we did in this bracket. 3 plus 6 will give you 9. Is it okay? Hello? So now the second one will be what? Somebody should tell us.
14t raised to power 6 dt.
Check it again.
14t raised to power 6 dt.
So where do you see 14?
The second one. Minus 14.
14t raised to power 5.
Okay. Take it again. Now, let me explain something to you. The question is how do we deal with d of t squared? You need to differentiate this first before you add it. Am I communicating? D means differentiation. Do you agree with me?
Yes.
This one means differentiation. So it simply means I will have 14 in t squared, t cubed, because this d, we don't need it. We only need the t, right? How do we make this one to be the t ordinarily? You differentiate 2, right? T. So it's going to be 2 dt. Do you agree with me?
Yes, sir.
So take note of that. Plus, so what, who can tell us what this one will be now?
28 t raised to power
No, the next one. We have to differentiate this one. 20 of
t square.
No.
T raised to power 6.
Then 2 dt.
Is it 2 raised to power 6 or 2 raised to power
2 raised to
five?
power 6. 2 raised to power 6.
It's
Which one?
product law. Sir.
No, t raised to power 6. This one
6.
will be 6. Then this one will be what?
3 dt raised to power 2.
Remember, you've differentiated it. Do you agree with me?
Yes, sir.
So, if I want to do it now, it's going to be t of 0 to 1. This will be 9t squared dt. The next one will be what? Minus
20,
what?
minus 28. Minus 28. T raised to power 5.
7.
What are you guys saying?
Minus 28 t raised to power 5 dt.
Minus 28 t raised to power 6. There is
No,
one,
sir.
there is 1 here, there is 3 here, there is 2 here.
Okay.
Do you agree with me?
Yes, sir.
Plus, this will be what? 60 t raised to power what?
T raised to power 8.
No.
Nine. T raised to power 9.
Do you agree?
Yes, sir.
Yes, sir. Yes, sir.
Because you have 6 here, 6 plus 2 will be 8. Plus
Plus
1
1.
will be 9.
No.
Take note of that anytime you are working on this. Now we can integrate. When you know the meaning of integration, when you integrate this one, you'll be what? 9
Which one?
t raised to power 3 over what?
3.
Minus 28 t raised to power 7 over what?
Over 7. Over 7.
Plus 60 t raised to power 10 over
10.
the lower one is t, 0 and 1. Upper limit minus lower limit. Now 3 can go in this one by 3 times. 3t raised to power 3. Please up your mic. Thank you. Minus 4t cubed 7 plus 6 t raised to power 10, 0 to 1. Upper limit minus lower limit. My upper limit is 1. I'll substitute 1 here. 3 will be 3 into 1 cube minus 4 into 1, 7 plus 6 into 1, 10 minus lower limit 3 into 0 minus 4 into 0 plus 6 into 0. So this will be what? 3 minus 4 plus 6. This one will be minus 0. So at the end of the day, 3 minus 4 minus 1, right? Plus 6 will give you 5. So 5 is the final answer. Any question?
So I have a question, please.
Go ahead.
Before you started integrating, that is why I have a question.
Yeah.
The line before you started integrating. Yes, where you have 28t raised to power 6. Why is it that there is no dt?
There's the t. Is omission. There's dt in all of them.
Okay.
Remember, everything has dt at the end of the day. Everything has dt. Thank you for that observation.
If you're adding, hello?
Go ahead.
If you added that dt again and you still wrote 28 raised to power 6 dt, doesn't it make it that line to be a 28 raised to power 7?
No. Remember, dt is just a function of the integration.
Okay, okay, okay.
Do you agree with me?
Okay. Yes, sir.
But because we have extra, we have the t, we have t. Let me call it. We can call it extra t. You remember? But anytime we had it, okay, it's like I gave you this. I said 2s dx does not make this one 2x squared. Does it make it 2x squared? No. Do you get it now? Have I answered your question, please? Okay, let's look at the B. The B part of the question says, the straight line from 0, 0 said along the straight line from 0, 0, 0 to 1, 0, 0. That is y equals to 0, z equals to 0. Because in this case now, 1 is here, meaning x is 1, y is 0, z is 0. That's the meaning. Then our dy equals to 0, dz also equals to 0. Y s varies from 0 to 1. Then the line, or then the integral, let me put it this way, then the integral over these parts of the parts is integral of 0 to 1, integral of x equals to 0 to 1. So we know the s is always equals to what? Remember, we have 3x squared plus 6y of I. And I know the I is already the x. Remember, we did that. Minus 14 what? 14y z dy plus 20x z squared dz. So it simply means that, remember the questions, this one means that y is equal to 0, z is also equals to 0. Anywhere you see those ones, substitute it. So you have s equals to 0, y. Then substitute this one. You know this to be 3 of x squared plus 6 of 0 dx minus 14 of 0, z of 0, dy of 0, plus 20 of 0, z squared of 0, dz of 0. At the end of the day, what do we have? So we are left with integral of s equals to 0, 1, meaning 3x squared dx. Others are 0. So you don't need to bother yourself. So I can just go ahead and integrate 3x squared. So what do I have? I will have it to be 3x cubed over 3 to 0 to 1. You don't need to say plus x or plus c again, because it's already definite integral. We have the value for the limit. So this one go with this. So you have s cubed of 0 to 1, which is same thing as 1 minus 0, which is equals to 1. That's the solution. Any question, please? So the C part of it, for our C says the straight line joining 0, look at it. The straight line joining 0, 0, 0, and 1, 1, 1 is given in parametric form by s equals to t, y equals to t, and z equals to t. Remember, initially it was given to be s equals to t, y equals to t squared, z equals to t cubed. But in this case now, our s is equals to t, y equals to t, z equals to t. So all we need to do is go to your integral of a dot dr, which means 0 to 1. That is t equals to 0 to 1. So meaning we have 3t squared plus 60 dt minus 14 of t and of t again, dt again, because this one is dt, not t squared, plus 20 of t and of t squared dt. So all we need to do now is to add all the t together. T from 0 to 1 will be. So how do we write this one? Can you add this together? This and this. Is it possible?
No, sir.
No,
Yes, sir.
because the power
In terms.
is different, right? So all
Yes,
we
sir.
have to do is just leave it the way it is by saying 3t squared plus 60 minus 14 what? T squared. Then plus what? All the t.
20 d cube.
Yes. So we can harmonize it. All the t squared can match together, while all the t can be. So we now have it to be integral of t 0 to 1. So when they give you this question, take your time. It will surely come. So this will be what? 60. This and this is what? Minus 11t squared plus 20 cube, or the t. So we can now integrate and substitute our limit. When you integrate and substitute your limit, what do I have? I have it to be 6t squared over 2 minus 11t cubed over 3 plus 20t4 over 4, 0 to 1. I know I only need to do the one of 1. I don't need to bother myself with the 0. I have here 3t squared minus 11 over 3 t cubed plus 5 t4, right? 0 to 1. Substitute my limit. I have 3 of 1 squared minus 11 of 3 of 1 cubed plus 5 of 1 4. Any question? If you resolve this one very well, what do you have? You will have 3 equals to 3 minus 11 over 3 plus 5. So which is what? 8 minus 11 over 3. So what do you have? 3 times this.
24.
Minus what?
Minus 11 over 3.
Which is what?
13 over 3.
That is your final answer. So if you're given this, please read it very well. Don't just jump into the solution. Say, yes, I know. No. Read it and look at those values very well. Well, let's look at another question in this regard. Let's say number 2. It says, find the total work. The total work done. You remember those of us in physics? In moving a particle in a force field given by F equals to 3xy I minus 5zj plus 10 sk along the curve s equals to t squared plus 1, then y equals to 2t squared, and z equals to t raised to power 3. From t equals to 1 to t equals to 2. So you have to be careful in solving this type of question. So let's look at the solution altogether. Total work done is integral of closure f dr. Don't forget that. Remember, before you integrate, you have to first of all nullify all the components. So when you see the question, you will identify it. I'm sure of that. So it's going to be integral of c. What is our f? 3xy minus 5zj plus 10sk dot the xi plus the yj plus the zk. So which is the same thing as integral of remember I dot I will be 3xy dx minus 5z dy plus 10x dz. So what do? I need to substitute my part now. I know x, y, z. What the meaning will be 3. What is my x? My x is t squared plus 1. My y is 2t squared. So I know it's dx. It will be d of t squared plus 1. Don't forget. Minus 5 of z. My z is t cubed. The y means d of 2t squared plus 10 is t squared plus 1. D of z is t cubed. So the way we solve the other one, we solve this one also. Remember, from here now, our t is 1 to 2. It's not 0 to something else. So we'll do this one, 1 to 2. So you have to merge everything together. So who can tell us what to do here? First of all, integrate this one. Differentiate this one so that you know what you are doing. Factorize these two out also. So let's do it one after the other. 3 into t squared plus 1. You have 2 here. I can factorize these two out. Let's do it. Okay, let's just do the one first. T squared plus 1 into 2 of t squared. Now let's differentiate this. What do I have? If you differentiate what is here, what do you have? This
2t.
Thank you. So you have 2t because 1 will turn to 0 dt. Let's just put it that way. 2t dt, right? So I can match all this out. But we are coming to that. Minus 5 of t cubed. If you differentiate what is here, you have what?
40.
40 dt. Then do the same thing here. Plus 10 of t squared plus 1. If you differentiate what is here, what do you have?
3t squared.
dt. So I can now go ahead and get it done. So what will I have? Anybody? Do we need to open the bracket of the one with plus 1 first? Or we need to integrate it the way it is?
Now let's expand it, sir.
We should expand all of them without
I
it.
know the one with square plus t and the one of 10 into bracket t square plus 1. Let's open it
Okay.
up before we.
Okay, let's try it. 1, 2. So this will be what? 3t squared, right?
Plus 3.
Plus 3. So what do you have here? Do we agree?
T4, yes, it is.
So you have plus what?
10 square, 10 square plus 10.
Are we sure? Are we sure? Okay. Silence means yes, we are sure. Okay.
Now, is dt not supposed to be part? After that, 3t square.
Yeah, it will be there. So now you can add or okay, what do you do at this point? I'm listening. What do you do?
So I thought we are still supposed to work on the 2t squared 2t.
Which of them?
From the bracket of 3t squared plus 3, close the brackets. Then open another bracket, 2t squared, close the bracket, 2t. The first one.
So what are we supposed to do here?
Yes, I thought we are supposed to write 3t squared
Right.
plus 3, close your brackets, then 4t cubed.
It's still the same thing.
All right.
It's still the same.
think-
Okay, let's do it the way you think.
I think we continue expanding.
Right? This is what you are saying.
Yes, sir.
Okay. It's still the same thing. dt minus 20t. So it's still the same thing. But now let's bring this one in now. Otherwise, we just be moving up and down. So if you expand it now, what do you have? What do we have? I'm waiting. 12 t raised to power what?
6.
Ah, bro. Do you agree?
Okay, yes, sir. Yes.
Okay. Let's just keep the t to the back. If you multiply this and this, what do you have?
Thirty t raised to power 4 plus 30 t raised to power 2.
So, which one supposed to come first?
Sir, please, how do you get the second 30 t square, sir?
3 multiplied by 10. 3t squared multiplied by 10 will give you this.
So there's a 3 at the extreme. Okay, I've seen it.
Yes.
I've seen it, sir.
So now let's add all the 4 together. What do you have? Do we agree?
40 t.
It can't be 40t.
Yes.
This one minus this will give you 10. So you have 12 t raised to power what? Plus 30t squared. If you are done, if you don't take your time, you will miss it at this point. You have to be patient and make sure you are precise. So look at the way we solve it one by one. So now let's do the upper limit first. Substitute your upper limit minus lower limit. So that's where you can use your calculator to make it faster. 2 raised to power 5 plus 10, 2 raised to power 4 plus 12, 2 raised to power 3 plus 30, 2 raised to power 2 minus lower limit. Two raised to power 1 squared, 5 plus 10 plus 12 plus 30. So what is the final answer, please? Do you think we are right?
No, we are not right. Though. We have not done the integration.
Good. Because all of you are not talking. I know majority of you will make these mistakes in the exam. Please take notes. Thank you, because I can see some of you are following while others are copying. Take it like that. So be careful, don't make that mistake. You need to, first of all, the next thing is to integrate. Now, when you integrate this one, what do you have? You have 12. 12 multiplied by what? You have 12 t raised to power 6 over 6 plus 10 of what?
T
5
raised to power 5 over 5 plus 12 t raised to power 4 over 4 plus 30 t raised to power 3 over 3.
So Now let's see which one cancel each other. Let's see. 6 here is 2 t raised to power 6 plus 2 t raised to power 5 plus 3 t raised to power 4 plus 10 t raised to power 3. 1 to 2. So you can see it's bring those values down. So you have it to be upper limit minus lower limit, making 2 of 2 to 6 plus 2 to 5 plus 3 to 4 plus 10 to 3 minus lower limit. 2 of 1, 6 plus 2 of 5, 1, 5 plus 2 of 1, 4 plus 2 of 1, 3. So what do you have at the end of the day? 2 raised to the power 6 is what?
64.
54 times 2. Or you multiply it by 2 already.
28. 128.
Please confirm it. 1, 2, 8. 2 raised to the power 5 is what?
32.
Times 2.
Now 64.
2 raised to the power 4 is what?
16. That's 48.
2 raised to the power 3 is what?
8. That's 80.
Minus. This is
2.
2 plus
2
2
plus 2 plus 3 plus 10.
So let's add everything together. Punch your calculator, what do you get? Yes. What do you have?
$303.
Thank you. The final answer. The final answer is 303. Look at the question you were given. It's so simple, right? So look at it. When they now put 20 marks or 10 marks in front, so you can see. It's not more, it's something you need to take your time and solve. Any question, please?
Who is there? I need my calculator on my this thing. It's on my bed, on my chair there. On my chair.
Jane, I will just remove you from the class if you do that next. Thank you. The class instruction is very simple. Mute yourself.
I'm sorry, sir.
Okay, so like I explained to us, I believe if you see any question in this regard, you will be able to solve them. Is that okay? Any question on that? So because of our time, we move into
That's a continuous question.
surface integral. But before surface integral, there are questions they can also ask us on a continuous way. I just thought of it now that I need to discuss with you. Let's look at this. Those questions. 3 says, if you have 5 to be equal to 2xy z squared, and you are given capital F, which is the 4, to be x, y, I minus z minus zj plus s squared k. And C is the curve x squared. C is the curve x equals to t squared, y equals to 2t, and z equals to t cubed from t0 to t equals to 1. The question say A. The question is evaluate the line integral A to B C by the R and B F cross the R. So remember what is our F according to our physics. We call it, we have F to be conservative and force, conservative force field. That's what we are talking about in this case. For conservative force field, we have the del to multiply them, and we can easily use del to solve them. You can have a different type of solution for this. But I will explain to us one after the other how we can use the call F will be and how to use it to multiply each other. Then, but before that, let's look at this. The solution will be remember is along C. Along C we have our y to be equals to 2xyz squared. So we have y to be what? So everything will be what? We know it here. It will be 2 of t. What is t? Our s is t squared. Then our y is 2t. Then our z is t cubed all squared. So what do we have at the end of the day? We have we have 4 t raised to power 9. Because this will be what? 6. 6 plus 1, 7 plus 2, 9. T raised to power 9. So we have this. Then, don't forget our R that I defined from day one. Our R is the same thing as xi plus yj plus zk. I believe you still remember. If you missed the class, please check the previous video on your course page or on the YouTube channel. You will see it on my YouTube channel. Then it can guide you. So in this case, if I have my x to be this, my y's to be this, I know them. You were given all this. Substitute. What do you have now? It will be t squared I plus 2tj plus 3 cubed k. So what's going to happen to my dr? My dr will be 2ti plus 2j plus 3t squared k. So remember the r we are using the other time is just the r of x, I, s, y, z. But in this case now we are given the value and we're using those values to multiply them. Then we can now say our integral closure of phi dr will be what? We know our phi with t. Our phi now will be integral of t equals to 0 to 1, making 49 into 2ti plus 2j plus 3t squared k. So I can go ahead and multiply them. Multiply each of them by 4, t squared, t9. So if I multiply them for 4t, what do I have? I will have, in this case, to be 8t raised to power 10 I plus 8t raised to power 9 j plus 12t raised to power 11. Okay, everything dt. So I can do it one after the other without delay. I know my limit is from 0 to 1. So it's going to give me, let me do the high. High is here, 0 to 1, 8 t raised to power 10 dt plus j, 8 to t 9, 0 to 1 dt plus k, 12 to t 11 dt, 0 to 1. So I can now begin to solve this problem. If I integrate this, what do I have? what do I have if I integrate this? I will have I. Let me integrate t. I will have 8/11 c raised to power 11. 0 to 1 plus j will be 8/10 t raised to power 10. 0 to 1 plus k. (12/12 t raised to power 12. 0 to 1. So if I substitute the value, anywhere I see t, put 1 there. I will have, at the end of the day, 8/11 high. If I substitute here too, I will have 8/10 j. This one will cancel, remain 1. If you substitute 1 there, I will only have k. Because k will multiply by 1 will give you k. So that is how to solve this type of the question. Any question?
Sorry, Prof.
Yes, sir.
That 49, 40 raised to power 9. I don't know.
So
How do you get it?
you get it, right?
Is that?
It's very simple. Let's look at it. You have 2 multiplied by 2 will give you 4. You agree with me? That's the only value you have there.
Yes, sir.
Now, here you have t raised to power 2 plus t, plus 1 rather, because t raised to power 2, this is raised to power 1, right? Plus 1.
Yes, sir.
Then 2 multiplied by 3 plus 6. So 2 plus 1, 3. 3 plus 6 will give you 9. So that's why we have 4t raised to power 9. Any question?
Thank you, Prof.
You're welcome, sir. So the next thing is we have to do cross. We all know B will be along C, we have F to be equals to XYI minus ZJ plus X squared K. Substitute our value there. What do we have? Well, what's the X now? Our X is T what? T squared. You have it to be, and Y is 2T. So if I substitute the value, what do I have? I have X squared, 2T squared, and 2T rather. So minus Z is T cubed. This one will be I minus T cubed J plus our X squared is what?
Hello, sir.
Yes, this is T squared. Sorry. Yes, go ahead.
Okay, you've corrected it. That's why I wanted to draw your attention.
Okay, thank you. So this one will be T squared raised to power 2. Okay. So when you resolve this one, we are talking about F, don't forget. This will be what? T raised to power 2T raised to power 3, I minus 3 cube J plus T raised to power 4 K. That is only F. Then, remember the question says, integral of C closure by F cross the R. I will did the R before now. Remember our dr is the same thing as what? 2ti minus what? Plus 2j, then plus 3t squared k. That is our dr. So what do I need to do? When you have a cross, then our cross will be, first of all, resolve the cross before multiplication, before integral. Will now be 2t cubed I minus t cubed j plus t for k cross 2ti plus 2j plus 3t squared k. So at the end of the day, we have cross, right? I, j, k. Which one come first? F. So let's extract those values. The value is this. I will be under I, 2, 3. J will be minus, don't forget, minus t cubed r t raised to power 4. So here we have 2t, 2, 3t squared. Remember, when you are doing the cross product, we did that. I will be what? Let's deal with I first. That means we are using this row against this column. The remaining one will cross multiply. This will multiply by this, minus this multiply by this. So you have to be careful. So you have it here to be minus 3, because this is negative. Minus 3, t raised to power, add the power of the t together, 5. Minus 2t raised to power 4. Because there's no t here. If there is t, you will add the power again. Any question? Okay, let me do it this way. I can see some of us are not satisfied, but you don't want to talk. So let's do it this way. Minus 3 multiplied by 3t squared minus 2 into t4. That is I. Let's look at j. But don't forget on your matrix, plus, minus, plus. That is the sign. Now, that's the rule of determinants that will guide us. So we have, in this case, minus j, right? Put the minus here. We are dealing with j. Let's say j. So let's remove this one. This is okay. This is fine. Then we are dealing with second column now. This second column, which is j, we paralyze. It remains this and this. So which is 2t raised to power 3 multiplied by 3t squared minus t raised to power 4 multiplied by 2t. So let's do the one of k. Plus k. We deal with this one with paralyze also. So we have it to be what? 2t cubed multiplied by 2 minus t cubed multiplied by 2t. Don't forget. So let's open the brackets one after the other. For your I, you have I to be this multiplied by this, you have minus 3t raised to power 5. That was what I did the other time. Minus 2t raised to power 4. That is my I. My j, minus j, don't forget, will give me 6 t raised to power what? 5. Minus 2t raised to power 5 again. Then plus k. This will be 4t raised to power 3. Minus times minus plus. So you have 2t raised to power 4. So we need to resolve them. So in this case now, you discover that something is common to them. Those ones that are common, you leave them alone. You don't bother yourself with that. The one with that, so like this one, now let's introduce our integration now. Remember, we have f cross dr. Will that be integral of I? Let's deal with I first. Our limit in this case is 0 to t equals 0 to 1. So we have minus 3t5 minus 2t4. You cannot deduct them, the t. Then the next one will be minus integral of t of 0 to 1. This minus this will give me 4. 4t raised to power 5 dt. Then plus k. You cannot add it together. 4t cubed plus 2t4 dt.
Excuse me, sir.
Go ahead.
Component J is missing, sir. You omitted it.
Oh, okay. So let's go ahead. We can now integrate it component by component. So at the end of the day, what do we have here? We have the first I. Let's integrate I. When you integrate I very well, you have negative 3t raised to power 6 over 6 minus 2 raised to power 5 t5 over 5 0 to 1 minus j. When you integrate, we have 4t raised to power 6 over 6 0 to 1 plus k, which is 4 raised to power t raised to power 4 over 4 plus 2 raised to power t over 5 over 5 is 0 to 1. So when you resolve, let's resolve the first one. What do we have? The component I will be what? What is I now? Let's resolve I. We have minus 3 over 6 minus 2 over 5. What do you have? Because when you substitute 1 into it, you have this. When you find the LCM, what does the LCM say? But you can cut it first. Okay, let's just resolve it first, so that you understand what I'm saying. If I want to do this one, and let's say I is still here, minus t raised to power 6 over 2 minus 2 over 5 t raised to power 5, 0 to 1. For I, let's solve the I now. We have it to be minus 1 over 2, right? Minus 2 over 5. So LCM here is 10, right? Don't forget the minus here. We have it to be minus 9 over 10. That is our I. We are adding everything together later. So let's look at the J. The J will be this is 2 over 3, right? 2 over 3 t raised to power 6, 0 to 1. You have it to be 2 over 3. Negative 2 over 3 J. Don't forget. Then the last but not the least, we have K. Our K will be t raised to power 4 plus 2 over 5 raised to power t over 5. So which is K will be, okay. It's going to be 1 plus 2 over 5. Which is 5. This is 5 plus 2, 7 over 5K. So therefore, we have our final answers to be minus 9 over 10 I minus 2 over 3 J plus 7 over 5K. So, any question, guys? Does it make sense to you?
Yes, Prof.
Thank you, sir. I believe your confidence is supposed to increase now. Some of those questions were asked to do, we should be able to solve them, or especially if you check the past questions, you see some of those questions are there for us to play with. Like I always tell us, try as much as possible to make use of those questions. And if you make use of those questions, you will see that they are actually very convenient for you to solve. By the time you go through this one again and again, repetition makes you, to be able to have a good hand on all those questions, to be sincere. Any question?
Sir, I'm sorry, I want to get clarification here, sir.
Go ahead.
So why do we omit all the T's and their powers at the end, and then write only the components with their coefficients?
Oh, okay. Thank you for that question. Remember, we are not omitting them. You are given the value. You are given the limit, right? We are saying at t equals to 0 and as t equals to 1? That was the question. So at any point in time, you are given the limit. The limit is on t. T equals to 0, substitute it. So when you say t equals to 0, you can't still represent t again. You already agree that t equals to 0. That's the question. If you go back to the slide, to the question. So can you see my screen now?
Yes, sir.
Okay, look at this question. At this point now, look at this. It said t equals to 0 to t equals to 1. From t equals to 0 to equals to 1. Meaning you have the boundary. So at this point, substitute after your solution, substitute t. Now, assuming we are not given t, we will leave our answer in this way. We will not substitute the t. We just leave our answer in this way. We just integrate and get this one done. After this one, we just leave the answer. But in this case now, we are asked to substitute. That's why you see definite integral and indefinite integral. Now we're using definite integral, which is 0 to 1. Have I answered that question? So you discover that anywhere you see t now, we substitute 1 there. That's why we have minus 1 over 2. And when you substitute t raised to power 1 raised to power 5 is still 1. Multiply by this, you have this. So that is what we did. Any other?
Thank you very much.
You're welcome. Any other question?
Can they help us put this one? I mean, on the platform, sir, so that we can still go through it again.
Which of them?
This particular topic we treated today.
Of course.